All right, class, welcome back to math. I am back today, so we are going to rewind a little bit and take a look at a lesson that yesterday the sub taught my in-person class. You all watched a Khan Academy video, but I'm going to spend a little bit of time explaining this. So on page 308 of your instruction book, everyone should be looking at this earthworm line plot, okay? Now, at the very least, what is a line plot? I would assume you all understood that from the substitute. Noah, what's a line plot?
It's a line of stuff, and you put or stuff above the things on the bottom to see how many were there.
Okay, so we just have almost looks like a number line down here, right? It goes in order. And then up top, we've got all these different lengths of earthworms. So this is just another way to make a graph. So every time you see an X above a number, that means one earthworm was this length. So we had 1, 2, 3, 4, 5 earthworms that were 5.5 inches long. We only had one earthworm that was 4.5 inches long. And you can see we have 3, 2, 3, 2. So we can count how many earthworms, right? How many total earthworms were there? What do we have to do to figure that out? Find the total number of earthworms. Cadence? Yeah, we need to count, in this case they're X's, we need to count how many there are, and that's how many earthworms there were, okay? So remember this, each X or point above your line represents one thing, okay? Everyone clear on that part? All right, now across the bottom, when you were younger, you've done line plots before, but we didn't use fractions. So this is the most important part of 4th grade line plots. I hope everyone's paying attention. We start at 4. Why do you think they didn't start at 0? Because this is important. You have to make your own lines sometimes.
Because there is no 0.
Oh, there's no earthworm that's 0 or 1 or 2 or 3. No. So we could add all of that, but it's kind of a waste of time. So they started at 4 because the first earthworm length isn't until 4.5. Okay? And we also didn't go to 100 inches because there were not earthworms that long, thank goodness. So you just have to put your data numbers between all your data points. So 4.5. How do I know? This is the tricky part for today. So everyone listen. We've got 4.25 right here, and we have 4 3/4 right here. Why is 4.5 in the middle? Why doesn't the 2 in this denominator match the 4s over here? I want you to think about that. Josiah?
I'm a stretching.
Okay. Noah?
It's half of 1/4.
Okay. Could I write that fraction as a 4th?
Yeah.
What would I write it as?
2/4.
Okay. So I just need everyone to remember, back when we did fractions, we could say 4.5 is exactly the same as 4, whoops, got my denominator and numerator switched around, 4 2/4. Is it okay when you're working on these problems to write an equivalent fraction that makes more sense to you underneath? Yeah, you can write them all in fourths if you want. We know how to do that. All right, so it goes all the way up. The numbers below the number line represent the length of the earthworms. Okay, now my next question and last question about this. Which earthworm is the longest and what's its length? And how do you know? I should see a lot of hands. This is an easy question. Which earthworm's the longest earthworm and how long is it? Cadence?
It is the middle one, and its length is 5 1/2.
Okay. That is the misconception where I get confused on number lines, okay? So you counted a different thing that's an important thing, Cadence. You counted which length of earthworm do we have the most of, okay? And you were right, 5.5, we have 1, 2, 3, 4, 5 earthworms that were 5.5 inches. So that's the biggest majority of earthworms are 5.5. But my longest earthworm is somewhere else. Angie?
6 3/4.
You're correct. How'd you know that, Angie?
We went over it with the sub yesterday,
Uh-huh.
and it's a big number, and the fraction's bigger.
Right. So as I go from down here to this direction, are my numbers getting larger?
And the 4.5 is the smallest.
Right. So the numbers down on this end are largest. My last X matches this length. So even though there's only one earthworm that long, that earthworm's 6 3/4 of an inch long, which is pretty good sized earthworm. More than half a foot. All right, any questions just on our earthworm picture? I know you've already done it. I wanted to review a little bit. Okay, so I'm going to pause you friends at home. We'll get right back to it in a minute. All right, so now students at home, we are on page 316 in your instruction book on number 18. Okay, we're going to walk through this one slowly together. So can I have a reader, please? Hayden, nice and loud.
A marine biologist at an aquarium records the length of the dolphins in feet. Make a line plot of the data shown below.
All right, so dolphins. First thing, to make this day a little more exciting, to wake you all up, we're going to draw a tiny little dolphin.
Yay.
All right, dolphins have a tail. They have a dorsal fin. Honestly, I'm not sure what that is called. Pectoral fin, maybe? All right, and then their head, remember, dolphins are all very rounded. Made them a little too skinny. All right. So, we're dealing with the lengths of dolphins. So that's how long they are. Quentin?
I don't think dolphins have feet.
No, they don't have feet. They just got fins. All right, so first thing, we need to make sense of what they are asking us to do. So I'm still going to box and highlight and go through my word problem. The marine biologist in the aquarium, none of that's really important. It's interesting. It makes it kind of click in my head, but I don't need to know it. She's recording the lengths of dolphins. Well, that is important. Lengths of dolphins in feet, okay? So all of these numbers are the lengths of dolphins. So we've got several different dolphins. Can someone count for me? How many dolphins did they measure? Just got to count. How many different measurements are there? I've not counted yet, so I'll trust you. Angie?
10.
10? Noah, did you get the same number? Mm-hmm. All right, so we have the lengths of 10 dolphins. So when I do make my line chart, how many X's should I see if I have 10 different dolphins' lengths? How many X's should I have on my line plot? Josiah? If we have 10 measurements, how many X's should I have? 10. It always matches, right? Okay. The hardest part of doing this is labeling your line plot. Okay, I get that. So first thing, let's see like about what our smallest number is and our largest number. Okay, I have an 8 here, a 9, 9, 9. Here's another 8, an 8, an 8. Okay, so I have 8 3/4, 8 1/2. What if I started at 8? Would that work?
Yeah.
8 is below all my numbers, but it's not like way below. Okay, so let's make this an 8. Okay, now what is my smallest denominator of or my largest denominator in all my fractions? We've got a 2, an 8, and a 4. Noah? The 8, okay? So I need to go up by 8s. Is that correct? Yes. So let's say this is 8 1/8, 8 2/8, 8 3/8, 8 4/8. All right, hope you see what I'm doing here. We're going to keep going up. Now, instead of writing 8 8/8, what would we put next? Angie?
9, but when we did it with the sub, we did it as 8 1/2 and 8 1/4. It doesn't really make any sense.
I know, so just listen to what I'm asking you to do, okay? So all we did, Angie, I went through and said, well, I have 2s, I have 4s, and I have 8s. I need to pick the largest denominator to make my chart. I promise this will be easier. Okay, please just listen. This is kind of a new lesson. Right now I'm waiting for all my students to finish writing down all those 8s, all the way up to number 9. All right, and now we're going to start over with 9 1/8. 9 1/8, 9 2/8, 9 3/8, 9 4/8. And I can see that we are going to have one plot that needs to be a little bit bigger. So we can add one more and say 9 5/8. All right, so to review all we have done, we looked and we saw, all right, our whole numbers are 8s and 9s. So we started at 8, and we saw that the largest denominator that we had to deal with was an 8. So that is what we did first, okay? Give everyone about 10 more seconds to write that down. Okay, the next part we need to do, look back at our list of values. Do we have some mixed numbers that have a denominator that's different than an 8? Do we have any denominators that are different than an 8? Emma? We also have 2s and 4s. So this is what I would do, okay? Please don't panic and just listen, because you guys, you are fraction masters. You know how to do this. I am going to also go through and label my fourths. I've got some 3/4, a 1/4. So when I have 1/4 and I want to make it equal to an 1/8. Okay, let's see, I got 1. I have 1/4, want to make it equal to 1/8. Whoop, I switched this around. Sorry, guys. So this 1/8 down here, if I want it to go into fourths, 8 divided by what is 4? 8 divided by what is 4? Right now we're just making an equivalent fraction. Instead of 1/8, I want to know what that would, sorry, I am like losing my mind. That should be 2/8. All right, Emma, what do I need to put here to make that true?
You need to put 2.
A 2. We have to put the same in the top. 2/8 is the same as 1/4. That's equivalent fraction. So if you're having trouble with that, we're going to keep doing it over and over. Your brain will remember. Okay, we did that a lot a few months ago. So I know, and maybe you guys already knew this, that 2/8 is equivalent to 1/4. So anywhere where it says 1/8, I can also write it as 8 and 1/4. So I also have a 9 and 1/8. This could be 9 and 1/4. Oh, sorry, my brain is still on vacation mode. 9 and 1/4.
What do you mean it's still on vacation?
You know when your brain's like out of whack because you're not used to being somewhere.
Where are you getting these 1/4?
Okay, Angie, we'd used equivalent fractions, which is a skill and a strategy we've worked on for a long time. I can take a fraction like 2/8, and if I multiply or divide by the same number in the top and the bottom, I can change it into whatever denominator I would like. So remember I just said we're going to have to do this process over and over, so be patient, okay? We're going to do it several more times. So I just changed 2/8 into fourths. I would say half of you know how to do that in your head now, okay? If you said I have 2/8, how many fourths would that be? You can change that in your head. Now let's think about the 4/8. If I have 8 and 4/8, how else could I write that? 8 and 4/8. 4/8 is kind of a special fraction. The 4 is half the size of the 8. What does that always mean, Cadence?
It's a half.
It's a half. Okay, if you don't know that 4/8 is the same as 1/2, you need to just turn your brain and think a minute, okay? If I have 4 out of 8 things, that is half, right? Okay, so just make logical sense of it in your brain. So anywhere where we have 4/8, we could also say, well, that's the same as 8 and 1/2. There's another one up here. 9 and 4/8 is exactly the same as 9 and 1/2.
Is 4/8 equivalent to 1/2?
It is. Yep. Very good. All right. So we don't have our 3/4 on here yet. Does anybody know which of our 8 fractions is equivalent to 3/4? Got to think that through. Noah, tell me which one and how you know that.
8 6/8, because if you times 3/4 times 2, you get 6/8, and then there's an 8 there, so you put the 8 to 6/8.
Okay. So we have 3/4 times something over something is going to give us the 8s. Okay? So what has to go here to make this sentence true. There's only one number that'll work. Thank you, the three of you that are participating. It's making class go a little bit better. Angie?
2 and 2.
Has to be a 2. 3 times 2 is 6. So Noah was right. 3/4 and 6/8 are equivalent. So anywhere we see a 6/8, we can also say it's 8 3/4. And that's it. Okay. So what have we basically done so far? That's the hardest part. That is the only part about line plots that's kind of tricky. Hayden?
Turning things into fourths and two.
So we had to find equivalent fractions, right? So here is your strategy. Step 1, you need to decide your endpoints, right? You need to figure out where your numbers stop and end. And then I would go through, choose your largest denominator, label everything, and then go through and find your halves and your fourths, okay? Maybe even your 3/4. Depends on what the numbers are they give you. So let's go ahead and put our X's on now, okay? This is my favorite part, kind of fun. So first number, and as I go, I check them off so I don't do them twice. And remember, we should have 10 X's when we're done. That's a good way to check yourself. So we need to put 8 3/4 on our line plot, which now should be easy, right? We did all the hard work. We already found our 3/4, 1/2, and 1/4. So where is 8 3/4? Josiah?
8 and 6/8.
Yeah, it's right here. So I'm just going to put an X. Okay, now I actually need to erase my work so we've got room for the line plot. All right, one value done. Right, 9.5. We already marked it. That's just easy now. 9.5, put an X. Done with the second one. Okay, go across and do all of your values. Find where they belong. Remember, if you have more than one value, you start making a tower. Okay?
I thought the 2/8 was equivalent to 1/2.
You thought that what?
I thought that 2/8 was equivalent to 1/2.
All right, well, think about it. If I have 2 out of 8 things, is that half of 8? If I have 2 8s, Andy, is 2 half of 8? If I split 8 in half, would I get 2? No. Okay, so if I want an equivalent fraction 1/2, right, the number has to be half of the value of the bottom. So 1 is half of 2. If I had 2 number 1s, I would have 2 things, right? What number do I need 2 of to get to an 8? Of course. Okay, so when you're thinking about what's equivalent to 1/2, your fraction always has to look like this, where the top is half the size of the bottom. Okay? So that's a good way to think it through. All right, so everyone keep on going with your chart. You should be able to find all of these because we actually wrote all the values. So I'm doing 9 1/4 next. I will give you a minute to finish that. Don't copy mine, you're doing yourself no favors. Finish yours, then check with mine. And you always want to make sure, if I had 10 different numbers, make sure you have 10 X's. All right, I see some of you are done, so I have a question. Why is this type of a graph even helpful? When I look at this, what does it help me realize just by looking fast? Zoe?
How much it is.
Yeah, well, I definitely am looking at, whoa, 3 of these were not earthworms anymore. I thought we were talking earthworms. because that would be a large earthworm. All right, we're talking dolphins. So we're in feet now. So I am noticing, wow, 3 of the dolphins that they measured are exactly the same length. And then I can also see which of the dolphins they measured. There, you know, like this guy, 9 5/8, there's only 1 dolphin that length. The 8 1/2 dolphins, there's 2. Okay, so this type of a graph or a chart is very, very helpful to see really quickly how many were the same height or length or whatever you're measuring. Okay, so that is the point of a line plot. All right, now the hardest part I know is finding your equivalent fractions. Okay, so we might just need to do some more practice with that in the back. But as long as you start by putting your largest denominator as your fraction, then you can find equivalent fractions for all the other values they give you. Okay, so we are out of time now. We're going to finish all of this when we come back. So good work so far. Any questions other than I'm having trouble with the equivalent fraction part? Other than finding equivalent fractions, are there any other questions? Angie?
I'm still a little confused of how like the numbers are equivalent. Because sometimes if I'm like in my practice, sometimes I don't know which numbers are equivalent.
Okay, so like I said, I'm going to pull people in the back to review equivalent fractions if that's your trouble, okay? But everything else about how to put them on the chart makes sense to you? Other than the equivalent fractions, like I said?
I just thought like we were gonna do it with stuff. Like
Hold on a minute, I can't hear because there's a noise. Go ahead again. You were confused about what the sub said yesterday.
No, we didn't do the subject yesterday. We did
Okay, when we come back, we gotta go. I am going to work with you on equivalent fractions, okay? All right, so class, I really do need to know though, does everyone understand why we put the x's where we put them? So other than equivalent fractions, I know that's confusing. That's what I'm asking you. Thumbs up or thumbs down? How are we feeling about the chart other than the equivalent fractions? Okay, so some of you don't even get the chart. Okay. All right, when we come back, I'm going to make everyone have a check-in system to make sure you're paying attention. Back of the room hasn't been listening all day, so I'm not surprised you don't get it. Okay, those in the front that have been participating, thank you. Most of you at least had a thumb up its side. That means you're getting the chart. We will review the equivalent fractions, okay? So friends at home, the only hard part about this is finding equivalent fractions for the numbers in the top row. So as long as you remember what an equivalent fraction is, I can change any fraction into any other fraction I want, okay? So you got to dig back into your brain, remember what those mean. Once you've got that, it is really a piece of cake, okay? So we'll keep working on it. See you later.